Lesson 7.7 is on exponential growth and decay. While a line is best modeled by slope-intercept form, which is y equals mx plus b, an exponential function is best modeled by the form y equals a times b to the x. Okay, we went over this last section. Here, the value of a tells us the initial starting value, which is the y-intercept of the graph, and the value b tells us if the function is growing or decaying. And it's important to note that exponential data will grow or decay more rapidly than linear data. Alright, so what this means is we have y equals a times b to the x. This a right here, that's your initial value. Alright, that's what you start with. On a graph, that's the y-intercept. And then the b right here, that tells us if the function is growing or decaying. So if this b is greater than 1, then we have exponential growth. So if b is greater than 1, you have growth. And if b is less than 1, you have decay. Alright, so we're going to identify the initial amount a and the growth factor b in each exponential function. State whether each exponential function is exponential growth or exponential decay. So in the first one we have y equals 4 times 6 to the x. So our a is going to be 4. Our b is going to be 6. Come on. And since 6 is greater than 1, we're going to have growth, exponential growth. Number 2, our a is going to be 100. Our b is going to be 1.02. Since 1.02 is greater than 1, we're going to have growth. Number 3, our a is 12, and our b is 0.20. Since that's less than 1, we have decay. For number 4, our a, we don't have an a there, so it's 0. And then our b is going to be 0.8. That's less than 1, so that's going to be decay. Number 5, our a is 40. Our b is 1.3. That's greater than 1, so we have growth there. And then finally for number 6, our a is 3. Our b is 1/2, or 0.5. That is less than 1. Oops. So we're going to have decay. Alright, our first example problem. Steve signs up for his first credit card and is reading about interest rates. After buying a laptop for school with the card, he builds the following function to model how much he will owe if he makes no payments on the card after t years. So the function there is f of t equals 1000 times 1.2t. Part A is the amount of money that Steve owes growing or decaying. What portion of the function indicates this? Alright, so we're looking at our b. Our b is greater than 1, so therefore the interest is growing. technical difficulties right in here. So the interest is growing because b is greater than 1. Right? So that answers the question, what portion of the function indicates this? Alright, now in part B we're asked to find what the interest rate is. So I wrote down here, so if we have exponential growth, our b is equal to 1 plus r, where r is whatever the interest rate is. So we just said that we have growth, so we're going to kind of use this formula. We know that our b is 1.2, so we're going to plug in. So 1.2 equals, so that was our b, 1 plus r. Okay, so what does r have to be? So 1 plus what gives me 1.2? Well, r would have to be 0.2, or 20%. So that's the interest rate. Alright, in part C, what is the initial cost of Steve's computer? The initial cost is your A, which is 1,000. And then Steve has heard that the credit card interest rates are very high. How much money will he owe after 5 years? How does this amount differ from the initial cost of the laptop? So what we're going to do is we're going to evaluate f of 5. So we're going to plug in 5 for t. I'm going to throw that in the calculator. Guys, this thing is being quite difficult today. Alright, let's see if this will write. So it's going to be $2,488.32. And that, ladies and gentlemen, is why we want to pay for things up front. We don't want to put things on our credit card where we have to pay interest. Alright, because ultimately, if he puts this on a card and doesn't pay it off for 5 years, he doesn't owe $1,000. He's going to owe $2,488, which is a considerably amount of money more than 1,000. Okay, the next problem, the function f of x equals 23,000 times 1.05 to the x gives the population of Willoughby after x years. So is the population growing or decaying? How do we know? So we're looking at our b, that's our growth factor. It's greater than 1, so we have growth. Come on. Alright, had to pause it. So there you have it. Population growth is what we have because our b is greater than 1. Alright, what percent is the population increasing or decreasing by? So we have growth, so our b is equal to 1 plus r. Well, our b is 1.05. That equals 1 plus r. Alright, so 1 plus what will give us 1.05? Well, R's got to be 0.05. Alright, and so what is that as a percent? You'd move your decimal place over 2 spots, so that would give you 5%. So we have 5% growth. The initial population in Willoughby is going to be our A there, so it's going to be 23,000. And then in D, what will the population of Willoughby be in 10 years? So we want to find F of 10. Okay, plug that in the calculator. And in 10 years, the population of Willoughby is going to be 37,465. We'll round. Okay. Alright, example 3 here. Go ahead and do this one on your own. And we'll skip ahead to number 4. And in number 4, we're going to be writing exponential functions. Okay, so it says condos in Newbury go up in value by 10% each year. The Kelly family's condo is currently worth $300,000. Alright, so what is the initial value of the condo? What is our A going to be? Well, it's currently worth $300,000. That's our A. Is the value of the condo growing or decaying? Well, it says that condos in Newbury are going up. So we have growth. Since this is exponential growth, we're going to use 1 plus R to find the growth factor, which is going to be our B. Now we have to write our R as a decimal. So our B is going to equal 1 plus R. Our B is going to equal 1 plus our growth rate is 10%, so that's 0.1 as a decimal. So B equals 1.1. Right, now we can write an equation to model this situation. Y equals our A, which is 300,000, times our B, which is 1.1, to the X. What will the value of the condo be in 10 years? So Y equals 300,000 times 1.1 to the 10th power. Plug that into the calculator. $778,122. 123 actually, let's round. Alright, so it's a pretty good piece of property that they're on. Alright, let's go to and do one more. Right? The local animal rescue league is trying to reduce the number of stray dogs in the county. They estimate that there are currently 400 stray dogs, and that through their efforts they can place about 8%. They can place about 8% of the animals each month. Right, so what is the initial amount of stray dogs? So your A is going to equal, they currently have 400. Alright, the stray dog population is decaying. So the Animal Rescue League is trying to reduce the number of stray dogs. So we have decay. Alright, since this is exponential decay, we're going to use 1 minus r to find the growth factor. So B equals 1 minus r. B equals 1 minus, our rate is 8%, so it's going to be 0.08. So 1 minus 0.08 gives us a B of 0.92. Let's write the equation. Y equals 400 times 0.92 to the x. And then what will the stray dog population be in 12 months? So y equals 400 times 0.92 to the 12th. And you'll get approximately, they're going to have 147 stray dogs. Okay, I lied. We're going to do one more. We're going to do number 6 here. So it says a population of frogs is 100 and increases at an annual rate of 22%. So we want to write down what our A is. That's our initial value. So that's going to be 100. Our B, so our B equals, so we have growth here, so our B is going to equal 1 plus R. We know that our rate is 22%, so B equals 1 plus 22% written as a decimal is going to be 0.22. So our B is going to equal 1.22. And so our function is going to be f of x equals 100 times 1.22 raised to the x. So what will the frog population be in 5 years? So that's going to be f of 5 equaling 100 times 1.22 to the 5th. So that's approximately 270. 270 frogs. Alright, so that wraps up, that's going to wrap up this lesson. 7 and 8, go ahead and do those on your own to finish up. I apologize for the technical difficulties in writing. It was probably a little bit frustrating to watch. I know it was frustrating to try and write, but we made it through, and we'll see you guys tomorrow.